In this video, we're going to discover and use the distance and midpoint formulas, and I'm kind of excited because this is a proof type problem, and then I just said proof and I lost 3/4 of you. But it isn't going to be too bad because it's not going to be like the geometry proofs that you remember from the olden days. Alright, so what we want to do is we're given a triangle ABC here, and what we want to show is that the line segment through the midpoints of AB, okay, so line segment AB, that's this one, right? I need to find the midpoint and then also the line or the midpoint of AC, so this one. So I want to find the midpoints of those two line segments and then connect the midpoints with a line segment because it says line segment through the midpoints. Okay, so a little bit of work there. And we want to see that that line segment is half the length of BC. Oh, okay. Well, let's chip away at it. All right. First thing is I want to find the midpoints of AB and AC. Okay. Well, midpoint, okay, it literally means midpoint, like halfway through, right? So if you look at AB, right, here's AB, what point do you think is about halfway through? Pause the video and just see if you can identify it. Upon inspection, you're probably like, well, it's probably going to be this point right there. It looks to be about halfway point, and the numbers, it's a nice grid curve or grid point, so maybe. But how do I find it mathematically? And well, the midpoint formula is truly as simple as taking. So if you have, we're going to say that we have 2 points. So point 1, we're going to call that x1. And then x1 and y1, x1, y1, and then point 2 is going to be x2 comma y2. Midpoint formula is literally as easy as taking the average of the x's for the x coordinate. Okay, so average, add them up, divide by 2, and then average of the y's for the y coordinate. Okay, don't think too hard about the notation. Average of the x's, average of the y's. Boom, done. So if I do that, average of the y's, this is going to be, okay, -4 plus 0 over 2, and then comma 2 plus -2 over 0. And lo and behold, I do get -2 comma 0, just as this point is identified. Okay, I'm going to do the same thing for AC. I want you to pause the video and do it for yourself. Okay, you do end up getting -1 comma 3. Okay, so great, we have our midpoint. Okay, fine. Moving on. So the line segment connecting these is going to be this line segment in red here, and I need to find, so I need to show now that this line segment in red is half the distance or half the length of BC, which is this other curve or this other line here. How in the world do you find the length of a curve? And well, I'm actually going to say, let's look at BC first. I noticed that, okay, this is a diagonal line, but I noticed that going from B to the right, that is, what, 2 units? And then going up to C vertically is, not 4, rather, it's 6 units, right? Oh, and then this is a right triangle, and we remember from geometry, yes, I just swore at you. Geometry, that we have the Pythagorean theorem with right triangles. We have c squared is equal to a squared plus b squared. And in a right triangle, the hypotenuse we call c, and then the other two legs we call a and b. Doesn't much matter which order you put them in. Nevertheless, we're able to find this hypotenuse length, c. And so if I do that in a right triangle, right, okay, so then that just means we have to square root both sides. Okay, we get c is equal to square root of a squared plus b squared. Do not distribute the square root. Okay, that's an exponent. Remember, we don't distribute exponents across addition. Moving on, and in this right triangle, if I do that, that's going to be 2 squared is 4, plus 6 squared is 36, so 4 plus 36 is 40. So in this case, I end up with c is the square root of 40, or better yet, reducing 2 square root of 10. Okay, now, other than using geometry, because again, I just swore at you, and I shouldn't swear at you, what we actually end up doing is, if we look at, we end up using a little bit of algebra, and we need to just look at it carefully. So again, what I can do is think of this as my point 1. Well, let's do this as point 1. So this is my x1, y1, and this is my x2, y2. Okay, and what I ended up doing was, okay, A was kind of the horizontal distance, right? So this 2 that I got here was really x2 minus x1. Okay, so, and that was A. And then similarly here, this 6 was the same as y2, 4, minus y1 of minus so minus a negative 2 in this case, and so this was b, and then all I did was say, okay, this is a squared plus b squared, square root of all that, right? So then that actually gives us the distance formula. Okay, and yes, I'm abbreviating. And so if I'm looking at the distance between 2 points, and here are my 2 points, it is really, okay, so this is our a square, or a, so this is going to be x2 minus x1, so take the difference, square that, and then plus, and then b squared is going to be y squared, or y2 minus y1 squared, okay, and that's our b, and then d is our hypotenuse length, right? Boom, done, okay? So now with all that, we need to return to the problem at hand. We just developed the distance formula and the midpoint formula. Great. So I know that BC has length 10, but I still need to find the midpoint, or the length of this other line segment. So if I look at, I'm going to say this, let's call this big D. Okay, so I'm going to say big D, even though it's little d, is equal to, okay, using the distance formula, all right, so I would do, doesn't matter which one's x, or point 1 and point 2, but I would do, let's see, so difference in the x is minus 1 minus negative 2, okay, square that, plus, and then I'm going to have 3 minus 0, okay, square that, I end up with square root, okay, 1 minus a negative 2 is 1, okay, so 1, and then square, well, 1 squared is 1, and then plus 3 minus 0 is 3, square that is 9, so I end up with square root of 10, okay? So indeed, the length of BC, and this is just some formal notation, don't worry about it, length of BC is 2 square root of 10, which is, and then we've shown is that big D is square root of 10, so it's half the distance, or rather, the length of this midpoint line is half the distance of the remaining side. Or sorry, yeah, half the distance of the opposite side. Okay, and so we've proven this, and more importantly, I don't really care about you knowing the geometry here. I'm more concerned with you knowing both the midpoint formula and the distance formula. So make sure to get these jotted down in a way that makes sense for you. Again, midpoint formula, I think of it as average of the x coordinates, average of the y coordinates. Distance formula, for me, I think of a triangle, and that's really all it is. And so in this next quiz questions, actually there's going to be 2 of them, I want you to generate what the midpoint would be, and also what the distance between the points would be.